All right, let's look at the homework 7.8, problem number 7. All right, so let's look at this improper integral. All right, so you can see that the integrand is going to have a blowing up, or maybe I should say a discontinuity when x equals 1, because it makes the denominator equal to 0. So I'm going to split the interval into 0 to 1 and 1 to 9. All right, so this is going to be equal to, all right, so you have an integral from 0 to 1, and then integrand is the same, 8 over cube root of x minus 1. And then you're going to start back up again from 1 and all the way to n. So you have 8 over cube root of x minus 1 dx. All right. So we have two improper integral to deal with. So I'm going to call this one. The first one, I1. So I'm going to call this guy integral 1. And I call this guy integral 2. All right, so let's look at the I1. All right, so I1 is going to be equal to, all right, so the troublemaker is 1, right? So we're going to have to replace 1 by t. Then we take the limit as t approaches 1 from the left-hand side, right? And the lower limit is still 0. All right, so I'm going to actually rewrite it. I don't like the way it's written, so I'm going to write 8. And then you have quantity x minus 1 to the, this is on the bottom, so it's going to be a negative power. And the cube root is equivalent to 1/3 power, right? So dx. All right, so let's go ahead and evaluate that. So this is going to be equal to, all right, so limit t approaches 1 from the left. All right, so antiderivative is going to be, so I'm going to leave 8 alone. All right, add 1 to the power, so it's going to be x minus 1. And then negative 1/3 plus 1 would be positive 2/3. 2/3. And divide by 2/3 equivalent to multiply by 3/2. So I'm just going to put 3/2 there. And then you are going from 0 to t. Right? Then we can cancel 2 and 8. So that's going to be 4. And you're going to have a 12 in front then. Right? So this is going to be, all right, I'm going to pull out, let's say I'm going to pull out 12. So I'm going to put 12 outside here. And then we have to take the limit as t approaches 1 from the left. Right, plug in t first, so you have a t plugged in. So you have a quantity t minus 1 to the 2/3 power, right? And minus, you plug in 0. 0 minus 1 is negative 1, so you have a negative 1 to the 2/3 power. All right, so negative 1 2/3 power is actually just 1, right? Because negative 1 squared is positive 1. Cube root of positive 1 is still positive 1. So this is going to be actually equal to 1, right? And then as t approaches 1, 1 minus 1 is 0. So this guy actually approaches 0. All right, so it's going to be negative 1 times 12 is negative 12. All right, so that's just the 1/2 of it. All right, how about the other one? So let's find I2. All right, I2 is going to be, again, troublemaker is 1, so I'm going to replace 1 by t. Then we're going to put the limit as t approaches 1, this time from the right, and then go up to 9. All right, then you have exactly the same thing. So the antiderivative is actually exactly the same thing. So I'm going to copy that. All right, so we're going to get this here. All right, So we're going to get limit. So I'm just copying what we did before. T is going to 1 from the positive side in this case. So this was just 12 x minus 1 to the 2/3 and going from t to 9, right? So this is going to be, right, 12 is factored out, pulled out, and t is going to be 1 from the right. All right, plug in 9, so 9 minus 1 is 8. Cube root is 2, so time square would be 4. So this is going to be 4 minus, right, t minus 1 to the 2/3 power. All right, so this time here, as t approaches 1, 0 to the 2/3 power, this is going to approach 0, right? And 4 is going to stay as 4. So 4 times 12 is 48. All right, so if you combine that, so it's a negative 12 plus 48 is equal to 36, right? So answer is 36. So it's going to be convergent, and 36 is the value. All right, let's check the answer. All right, I came back and looks like we got this one correctly. All right, that's it. I hope that this was clear.